So cosine u is the same thing as 1 over what? Secant u. Tangent u is the same thing as 1 over cotangent u. Cosecant u, 1 over sine u. Secant u is 1 over cosine u. And cotangent u is 1 over tangent u. So I would maybe use these if I saw in an expression, I saw something like 1 over secant u. What do you think is more simple, to have a fraction or not a fraction? Probably more simple to not have a fraction, so maybe I would substitute out 1 over cosecant u and make it sine u instead. Or maybe I do want a fraction for something else, so maybe I could substitute the other way. But these are totally equivalent, so in any expression or equation, we could substitute these for each other. Over here I have an example that says sine x multiplied by cosine x is equal to 1. So it looks like there's nothing to do here. But what we're going to do is we're going to show why that equals 1. We're going to show all our steps to show that it really does equal 1. So when I look at these, is there something that we just went over here that I could substitute for either sine x or for cosine or cosecant x? Yes, Josh?
You could substitute cosecant x with 1 over sine of x.
So I just used the substitution property because they are equivalent. I substituted those. Now we do have to understand how to be able to multiply a whole number, which is like the sine x, with a fraction, 1 over sine x. How do I multiply these things together?
Whole number over 1.
Okay, whole number over 1. And then what? Straight across. That's how you multiply fractions. So sine x over sine x. And then what is sine x over sine x? 1, right. So did you see how I wrote down my steps so anybody looking at this could follow what I did? When you take a test or a quiz, and your teacher has to go look and read your mind and figure out what you did, you better make it clear to me. Because, like, I don't know how else I'm going to grade it if I can't figure out what you did. This is what I'm going to be doing for this stuff. So it'll take me forever to grade. Okay. I'm not looking forward to it. Anyway, but these are important if you're going to ever manipulate equations in the future, which would be used. I know we used a bunch of this in calculus, but I don't remember a whole lot. But I know we used a bunch. The next section is quotient identities. What is quotient? What does quotient mean? Dividing, or it's like the answer to a division question. So this has to do with dividing. Right now it says tangent u. So we're going to rewrite this as a division problem. You guys know from our last chapter that tangent is the same thing as y over x. You also know that y is the same thing as what? And cosine is the same thing as x. So I can rewrite tangent u as sine u over cosine u. So that is a division. And with that thought process, can you rewrite cotangent for me? Okay. Question? Next are some examples, and I'm going through these examples to help you in the future, just to understand, like, how can we multiply together sine x times sine x? Okay, so I want you to really understand why the answer to this looks like what it looks like. So I'm going to use numbers. I'm going to do it like in the top corner. So I'm going to do an actual example. I'm going to multiply sine of, how about 30 degrees? Multiplied by sine of 30 degrees. I picked one that I'm sure is your favorite. How would I find the answer to this? How would I simplify it? What do you think? Take a guess. Oh, you're going to have to be brave. Yes, no problem.
Blank over
So we're going to figure out the sine of 30 degrees first. And to replace that, substitute. Then I'm going to have to do 1/2 times 1/2. By the way, if anybody's curious, 1/2 times 1/2 is 1/2 squared. So you do. And what is 1/2 squared?
1/4.
Okay. So now here's a silly question. What part of the original question, what part did I actually write squared? I wrote the sine squared. I did not write the angle squared. You see, this is not the angle. So I used the angle and I did the sine at that angle. I did the sine at that angle, and then I squared the sine answer. So when we do sine x multiplied by sine x, and there isn't like an angle in there to find the answer, you simplify that by writing sine squared x. So it's the sine part that's actually getting squared after you find the sine of that angle. It is not the angle that gets squared. So that's why that little 2 is in a weird spot. So what would tangent x multiplied by tangent x equal? Tangent squared x. Now that is not the only thing that that could possibly equal. Because it just depends what we want tangent x times tangent x for, like how we want to use it. It doesn't only equal tangent squared x. It could equal sine squared x over cosine squared x, because tangent squared x is the same thing as sine times sine over cosine times cosine. Is there something else that just curious, is there something else that tangent squared x could have equaled instead of this, using the stuff that's on our paper? Secant squared x over cosecant squared x. So what Linus did is she just moved the cosine up, which is if we have 1 over cosine, that's the same thing as secant. Or if we have sine, that's the same thing as 1 over cosecant. So she just used their reciprocal identity. So is there something else that tangent squared x equals? 1 over cotangent squared x. So there's more answers, but there's lots and lots and lots of different things that one thing equals. So that's where people get nervous. Well, which one do I use? Well, it just depends on what you want to use it for. That's where doing your work is going to be very helpful. Then you'll start seeing and understanding. I can't tell you which one to use. It just depends. Okay. So the next one, if I have cosine squared x divided by cosine x. Anybody have an idea? Jeff? Why?
Okay, well, maybe down to cosine x multiplied by cosine x over cosine x. You can cancel cosine.
Now, a lot of people make mistakes on when you're allowed to cancel and when you cannot. A lot of people, and probably in here, will do the same thing. And that just comes from, like, did you really understand it after the past 3 years of doing math over and over again? Did you really understand when you can cancel? So we're going to have this discussion many times in here. But you can cancel if it's being multiplied. If you can factor it out, you can cancel it. You cannot cancel if it's being added. You cannot cancel next to an addition or subtraction sign. Now, I just said that, and it just went like this to you guys. Okay? So when we see those examples, I'm going to bring it up. And when you make those mistakes, then I'm going to bring it up over and over and over again. But I know people are going to make those mistakes. All right, how about the next one? Cosine x, cosecant x divided by secant x. Jasmine?
Cosine squared x.
Okay, so you're going to have to tell me how you got there first.
Okay, cosine x over, what, yeah, wait, yeah, cosecant x, wait. What?
The cosine?
The
Or
cosecant.
the cosecant? Okay, so what you're doing is you're using the reciprocal identities,
Yeah.
right? And the reciprocal of secant x is up here, 1 over sine. So you can take that secant and move it to the bottom of the fraction. And same thing, or the cosecant. And then same thing with secant, 1 over secant, because secant's on the bottom here, so that's like 1 over secant. Maybe if I separate these, it'll help see what I'm trying to say. This is what I'm trying to say. So cosines multiplied by cosecant, which is divided by secant, or same thing as multiplying by 1 over secant. So when we're looking at these pieces, this one is the same thing as 1 over sine, and this one here is the same thing as cosine. So she said, do cosine x, make that one into cosine x, move that one down to the bottom, sine x. Right? That's what you said? And then you took it further and you said cosine squared x over sine x. Okay? I'm going to tell you that there is a different way of writing this. Maybe we would need it a different way. If you look at this one right above it, this is one way of writing it. Here's a different way of writing it. Possibly we would need it. Does anybody see a different way of writing after this first step? What do you think? I know, this is the scary part, is saying the wrong answer, but it's okay. Take a rest. That's the worst thing I would say. No, that doesn't work.
Cotangent times cosine x.
Did you say tangent?
Cotangent.
Okay, I couldn't hear what you said. So if you look right here, we have cosine x over sine x. That is cotangent. So yeah, you could also write this as cotangent x cosine x. I can't really say which one's the better answer because it just depends on what you would use it for. So today's lesson isn't necessarily the whole thing. This is just baby stepping into what would you use that for? Was that our lunch? Okay, we'll do the rest of it when we get back. So on the back of the front page, we have something called Pythagorean identities. And you have heard of the Pythagorean theorem before, yes? Maybe a few times? So you'll see that right here, this is set up from the triangle, any triangle in the unit circle. Where the unit circle, the radius is 1. The a squared and the b squared would be like the two sides of the triangle. So if you do a squared plus b squared, it equals 1. But instead of a squared and b squared, we're using the sine for the y and the cosine for the x. So sine squared plus cosine squared u equals 1 is a Pythagorean identity. But what I can do is I can manipulate this to give me more identities that look similar to this, and they're just in different order. So what you're allowed to do is, since this is an equation, I can do whatever I want. I don't know, subtract sine squared u from both sides. So if I subtract sine squared u from both sides, I get cosine squared u equals 1 minus sine squared u. So that is another Pythagorean identity, where if you had 1 minus sine squared u, you could substitute it for cosine squared u. I can manipulate this original identity a different way. I could subtract cosine squared u from both sides of the equation and get sine squared u equals 1 minus cosine squared u. It says there's 9 of them. There's not 9. There's like many many more than 9. But we're only going over them like the main 9, I want to show you something that keeps happening in our assignment and our notes today. So I'm going to do it now so we don't have to come back and do it. I can manipulate this one further, this one right here. If I subtract 1 from both sides, now I have sine squared u minus 1 equals negative cosine squared u. So that's like another version of this Pythagorean identity. So as long as you're doing the same thing to both sides, you can have infinitely many versions of this. They're just not all going to show up in our assignments. So using the thought process, we can do whatever you want to both sides. I'm going to take this original one and I'm going to divide everything by sine squared u. So I'm going to have sine squared u plus cosine squared u equals 1. I'm going to divide everything by sine squared u. I'm going to simplify what I have, and that's going to be another identity. So sine squared u over sine squared u,
1.
that's just 1. And then what's cosine squared u over sine squared u? Tangent squared u. Nope. Cotangent squared u. And then 1 over sine squared u is? So now that looks completely different than our original Pythagorean identity, but it is equivalent to it. And then using this one, number 4 that I just did, I could subtract cotangent squared u from both sides. So I can have 1 equals cosecant squared u minus cotangent squared u. Or I could have taken number 4 and subtracted 1 from both sides. And have cotangent squared u equals cosecant squared u minus 1. Again, we're just manipulating these using rules that we've already learned in math that you can apply to correctly apply. All right. The third kind of just like main, to get the last 3. If I take this original one, number 1, sine squared u plus cosine squared u, and I divide everything by cosine squared u instead. So my 7th one would be, let's see, what's sine squared u over cosine squared u? Tangent squared u plus cosine over cosine is 1 equals 1 over cosine is secant squared u. So that one again looks completely different, but it just came from the original. And then we can manipulate this one. I could subtract 1 from both sides. So I'd have tangent squared u equals secant squared u minus 1. Or I could have subtracted secant, getting tangent squared u minus secant squared u equals, whoop, that's not what I meant to do. I could do that, but that's not what I meant to do. Okay. Subtract the tangent squared. 1 equals secant squared u minus tangent squared u. If I had subtracted the secant, I'd also have to subtract the 1, and we'd have something equals -1. You could do that too. This just isn't just the main ones. Okay, so you have 9 of these that you can refer to as you do your assignments as well. So the assignment is going to be just like these notes, and we're going to simplify. This is not the only time we'll use this stuff. We're going to use it more for actually solving equations, but for now we're just getting used to these, so we're going to simplify. When you've simplified it, it should, not every single one does, but it should get to 1 trigonometric ratio or 1 number. Not all of them do, but almost all of them do. Okay? All of these on here do, just in our assignment. I know there's like one that doesn't. Okay, so I look at cotangent x multiplied by tangent x. Anybody have an idea of how I can simplify this so it's one number or one trigonometric function? Yeah.
Tangent x over tangent x.
So you are taking, so we're gonna talk through this. You are taking cotangent x and writing it as 1 over tangent x. So that's what I need to see. Which is going to give you tangent x over tangent x, which is 1. So we have a simplified version of that. Okay, the next one, cosine squared x, cosine squared x. I'm going to simplify this down so we can't have an addition sign. Can we add these together? Do I have an idea? Yeah.
You could change that because cosine or sine minus, wait, you use sine minus plus.
Cosine is equal to 1 minus sine squared?
Yeah. Plus
Wait,
sine.
how can you use one? There's no, you wanna do an example?
Wait,
Like,
for this?
yeah, it's not the same. It's not equal, it equals one.
Yeah, I know. I know. This is not, there's no equal signs over here, right?
Right.
You just have to find what this equals.
Oh,
Okay, there's no equal signs, but you're going to simplify it. So now, I'm going off of what Avery said, which may not be the fastest way of doing it, but that's okay. He said, I don't remember what he said. You said take cosine squared x
Change to 1 minus.
and write that as 1 minus sine squared x. Then I bring down my plus sine squared x. And why would I do that? Because these will cancel each other out and we'll just get 1. Can anybody think of a faster way that I could have gotten to the answer 1? What did you say? Like that is a given identity, so you could just say, oh, that answers 1. Like you didn't have to, but you see it works other ways too. So you didn't realize that right away, and then you said, oh, well, this is that, and then these add together and I get 1. It's okay also. All right? All right, the next one. 1 minus cosine x times 1 minus or 1 plus cosine x. Is 1 minus cosine x on here? Is 1 minus cosine x on here? When it's Pythagorean, it's got to be squared. Is this squared?
Yeah.
So do not switch that. Do not say, oh, well, I'll just write sine, because this one's not squared. That it doesn't work that way. Pythagorean ones don't work that way. Okay? So instead, since these are multiplying, I'm going to multiply them out. I'm going to, use the FOIL property, distributive property. 1 times 1 is 1. My outside is plus cosine x. My inside is minus cosine x. My last is minus cosine squared x. And since these were conjugates, one was plus, one was minus, the middle terms always cancel out. And I get 1 minus cosine squared x. Is that a Pythagorean identity?
yes.
Yes.
Yes, and that one is equal to sine squared x. Yes, okay.
Do I have to, like, write the first part, or can I just do the 1 minus cosine squared x? You want to show?
How will I know what you did? Because so this is the thing, it's like, I'm going to have to grade this, and I'm not grading it while talking to you. I'm looking at your paper later, probably on a Sunday, trying to figure out what you did like 2 days before. Do you want to make it as clear as you can to somebody else what happened? Okay? How about the next one? 1 over sine squared x minus 1 over tangent squared x. So since this is a reciprocal, so you're using that reciprocal property, cosecant squared x minus cotangent squared x. That's not it, yeah. Any ideas? I see squareds, so I'm going to start looking over here. Which number?
Number 5.
Number 5. Look, it is number 5. So our answer is 1. I would like to encourage you to work ahead, because I want to see if you're understanding what to do, or if not, then I can help that more. I'm going to pause the video just for a moment so that you guys can try some of these on your own, and then we'll go through all of them. But I just want to make sure that everybody has their opportunity to try it. You know, you can keep working. But when I look at this one, sin x could be 1 over cosecant, but I don't know if that's going to really help me. When I look at cotangent, there's 2 ways I could go. I could do 1 over tangent. But what's that going to do to sine? Nothing. And there's another way I could write cotangent. What's my other way of writing cotangent? Cosine x over sine x. So what's that going to do to sine?
Cancel out.
Right, so there's like multiple ways of doing some of these. And if you're thinking in the future, before you even like write it down, like, what is that going to give me? Why would I want to switch that? So I'd want to use the cosine over sine so that those cancel and we get cosine x. So the next one, 1 over cosine squared x, that is a Pythagorean, which is sine squared x. And then that sine squared x is the same thing as sine x times sine x. So I'm able to factor out one of those sine x's. If I'm able to factor that out, factor means like unmultiply, then I can cancel it. I cannot cancel it if it's next to addition. The next example, 1 minus sine squared x. I'm looking at first because of that minus sign, and I feel like that might be an identity. And you look at your Pythagorean identities, that one is an identity. That one is cosine squared x. And this one's secant. And I know secant and cosine are reciprocal, so I'm going to reciprocate that secant. And those will cancel and get 1. Equal 1. So this next one I'm looking at, I see a cotangent, I see a secant, and I see a sine. So I start thinking about cotangent. Am I gonna want cotangent to be 1 over tangent, or am I gonna want cotangent to be cosine over sine? By looking at the rest of the stuff. Cosine over sine. And then secant I will make into 1 over cosine x. And then I'm going to leave sine x. And what's going to happen? Cancel, 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 1. Very satisfying when everything cancels. Oh, this one right here, what do you think? Ideas? Cosecant times sine? What should we do with the cosecant? Okay. Okay, then I go and I look to see if sine squared x minus 1 is one of those identities. And this is why, that's why I did that with you. So this one, I Like we had 1, 2, 3. This one's not really, if you look it up on the internet, this isn't one of the main ones. But you can manipulate those main ones to get you what you want. So where I have sine squared x minus 1, that's just equal to negative cosine squared x. And then once you try that last one, and then I'm going to pass out your worksheet. And you've got those 2 worksheets for your assignment today. And you guys will come see me tomorrow if you have any questions.